Well, hello again. So we continue our exploration of our textbook on Chapter 4. Chapter 4, Insolation and Temperature, has to do with just that. Insolation meaning incoming solar radiation, so the energy from the sun, and how that creates different temperature patterns on the surface of the Earth. So our main source of energy is, of course, the sun. Temperature and heat. It's important to know the distinction between the two. Heat is a form of energy, and temperature is basically a way that we measure how concentrated that energy is. Think about this. What if you have a needle and you put it on the fire, right? Well, that needle would get very, very hot, and you won't want to touch it. So the temperature of that needle will be high, but the amount of heat it contains will be not that high because it's a needle. It's not that big. Okay, so just an example so you can see the difference between temperature and heat. So as I said, solar energy, that is the main source of that heat that we get on Earth. Here is the electromagnetic spectrum. So you saw this in Chapter 2 when they were talking about remote sensing. So familiarize yourself with the electromagnetic spectrum and the part of that is visible light. And here is another figure that shows you that. One important thing about this figure is the amount of energy, right, that we get from the sun. So most of the radiation from the sun is in this part of the spectrum, which is light. Whereas most of the radiation that the Earth emits is in this part of the spectrum, which is heat. Okay, so we call this short wavelength, and this long wavelength. Okay, or solar radiation, infrared radiation, light, heat. Different terms for basically the same thing. This page we have some very useful terms: absorption and reflection. Absorption meaning energy that is absorbed or taken in by a surface, and reflection is kind of the opposite. Reflection is energy that bounces right off a surface and does not interact. A good term to know here, albedo. Okay, so reflectivity of an object. So basically a percentage of how much of that light that reaches a surface, how much of it is reflected. So a body that has a high albedo may have 80-90% albedo, meaning that 80 to 90% of the light is reflected, and those tend to be lighter color surfaces. Okay, so things like snow and clouds have high albedo. Things like a dark roof or a road would have a low albedo. Okay, so here we move on to the greenhouse effect. The greenhouse effect is natural. However, we are enhancing the greenhouse effect by adding special gases to the atmosphere. So these two figures are just showing you basically how it works. Basically, we have light or shortwave solar radiation from the sun reaching the Earth, where it is absorbed by the surface, and surface means both land and water. And once that is absorbed, it becomes heat, and then it's re-radiated, not as light, but as heat. And basically the atmosphere acts as the windows on this car. They block some of that heat from leaving, and they help warm up the earth. We, of course, need the greenhouse effect. If we didn't have it, the earth would be a frozen snowball. But we don't want too much of a good thing, because then we get global warming. Convection is another good term to know, because we'll talk about it more in the future. And basically, in convection, we have a vertical movement of heat in a circular fashion.